Hi, I'm Gordon, and this is the second video in a series where we're working with BERT and putting together a sentiment classifier, and to be more specific, an ensemble classifier for sentiment. Now, we will be leveraging this into sort of a first pass attempt at what is known as aspect-based sentiment analysis. And that means that later on we'll be needing to get to some topic modeling, and I'm going to save that for the next video. This should be the middle video in a three-part series. We might need to go to a fourth, depending on how much material I want to cover in the next segment. But for right now, I'm going to try to keep this as brief as possible. This is really just about showing a few processing steps and then taking a look at some of the results from our initial sentiment analysis, okay? So if you haven't seen the first video here where we we went through the process of training a BERT model and performing sentiment analysis on our corpus, please go back and watch that. I'm not going to cover that material again. As a quick reminder though, we went through that pre-training process and then we asked that model to go sentence by sentence through our corpus and tell us whether each sentence was positive or negative. A majority of them are positive. Our classifier wasn't incredibly impressive, but it did an okay job. And you'll see that when we combine three classifiers together to get an ensemble prediction, what we end up with is actually much more reasonable. And the way that I accomplished this, I did go through this process probably 4 or 5 times, and each time I pickled the data frames for sentiment predictions. And now I'm simply, for this middle step here, I'm simply going to read all of those data frames in together. And you can get an idea here, by the way, the shape, right? There are 1,338 reports in total, so that's the number of rows. The longest report was 32 sentences long, so that's why I have 32 columns in these data frames. This code here, this is what allowed me to create the index and the columns for each data frame as I created it, both the description and the sentiment data frames. Here's a quick look at what each sentiment data frame, what it looks like when it first comes out. We've got positive, negative, and then a bunch of none. The reason we have all of these none predictions is that, the longest report was 32 sentences long, which is remarkably long, and a vast majority of these were, 10 sentences or fewer. So we have to be able to deal with this, and in this case, I've filled in all of these none spaces with a neutral, classification. And here's what the data frame looks like after we do that. This is exactly what was done up here. So it looks like I've got that in this notebook twice. It's my mistake. But here I just go through, I'm pickling these so that I can read them in later, right? And now, for sort of the new material here, this is me reading all 3. I'm just going to read 3 and not 4, because I found that the 4th one maybe wasn't as good, but the first 3 work pretty well together. So here we're just reading in 3 different sets of sentiment predictions, and the description as well. And with the description, actually, as you can see here, we've still got that same issue of we're just seeing none values wherever there was a report that wasn't, that long. So we need to deal with that as well. Here I'm just saying, okay, we're going to fill this in with a sentence. In this case, the sentence I put together is filler confabulation betokening truant denotation, and that is just a fancy way of saying this is, filler for where there's a lack of words and meaning. I will point out, I'm not just being fun with this sentence. These words were specifically chosen because they don't appear anywhere else in our corpus. When we get to topic modeling, you'll see the value of that. Okay? So these words are exclusive in this corpus to our filler sentences. And you can see at this point, all of those are in here, right? So when we're working with an ensemble model, we do need to change these values into numeric values, of course. And, well, we would probably want to do that regardless, but here we're replacing all of these values with 1, -1, and 0 for positive, negative, and neutral, respectively. And this is commented out because we're not using that fourth data frame, as I mentioned already. Down here, we're just combining all three into one single data frame. So now we have sentiment predictions for each sentence, right? And that goes all the way through the player report. So to give you a quick glimpse of what that ends up looking like, or what the product is, I'm going to go ahead and pull up just a slide here, and I hope that you can read this. I hope that it's not, the font is not too small. But I'm going to read this to you. So this is one player report, broken down sentence by sentence, with the first model, the first model, the second model, and the third model showing their predictions. Okay, and I'm just going to read this to you. So the first sentence, this is for a defenseman named Eric Chernak. It says, Chernak has also been a very impressive prospect for some time, being one of Slovakia's top under-18 products of the past 10 to 15 years. Unequivocally positive statement. He has a ton of high-level experience, including a great season in Slovakia's top league and playing for the national squad. Again, unequivocally positive. The next sentence is as well. You can take my word for that. Next sentence is as well. Then we get to a negative comment. I keep moving ahead in my slideshow here, and I don't mean to. This negative statement says his main issue is his hockey IQ, as he shows a moderate frequency to make bad decisions on hits, pinches, and puck decisions. All three recognize that this is negative. Fantastic. And then we get to something interesting. It says at the top of his game, he can look like a dominant two-way defenseman, but that is not always the guy who shows up. 2 of our 3 models are saying this is a positive statement. 1 is saying that it's negative. When we think about how do we want to actually classify this, it's valuable to be able to recognize this level of ambiguity. And, the text data that we're working with here, I pointed this out in the last video, but I want to restate the point. Very different from a collection of tweets or a movie review data set, in that you're usually going to see a lot more even-handed of an assessment, right? The sentiment isn't going to be incredibly strong one way or the other most of the time. Occasionally you'll see a report that's just absolutely glowing for, Connor McDavid or a player like that. In this instance, the report that I just showed you, we can see the real value of having 3 different classifiers, because we are going to get some disagreement, and that disagreement is going to help us hedge how we actually feel about sentences like that last one, which are legitimately ambiguous and don't have a clear positive or negative slant. They contain both. Okay, I'm going to go ahead and stop this video here, and in the next one we will pick up with the topic modeling aspect of this, which is going to be everything that we need at that point to sort of combine sentiment and topic modeling into aspect-based sentiment analysis. All right, thanks so much for listening.